Chiliong, are we all good? Okay, cool. All right, well, I'm starting anyway, even if you're not seated. Well, welcome to Ruby Tuesdays number 62. Amazing. It's already number 62. We started 2013. I was looking at our GitHub pages for all of the keynotes of this. If you're interested, go to github.com/klxrb. You'll find all of the slides from the very beginning. So it's actually interesting. Welcome. Thank you to Fave for hosting us this month. If you're interested in the Wi-Fi, that's Fave Guest AH 2.4 or Fave Guest AH 5. The password is Fave Wi-Fi here. Nice. Yes, it's brought to you by Fave and the KL Ruby Brigade. Yes, this place has Wi-Fi. If you want to be part of the community, we are on Facebook at KLXRB. You can also go to the website at rubybrigade.my. You can also find us at meetup.com. Actually, who found us through meetup.com? Who found us through the Facebook page? Who found us through the DevCami meetups link? No, nobody? Okay. So we are at meetup.com. If you want like more announcements of meetup related stuff. We also share the meetup with the Penang group. We do it like every 2 weeks. So Penang happens, and then 2 weeks after that KL happens, and then 2 weeks after that Penang happens. If you're interested in whatever we are doing with GitHub, with open source, with these keynotes, it's at KLXRB in GitHub. And if you would like to chat with the community, it's at Slack. You can go to rubybrigade.my/Slack invite, or you can go to bit.ly/rubymyslack. And for a larger community, not just for Ruby, but lots of other different engineers, you can go to engineers.my. And if you're like me, that I always keep what meetups are available, you can go to devcami.com/meetups. You'll find all the other meetups. I think tomorrow there will be a Rust meetup. So if you're free for tomorrow, then you should go there. All right, I will introduce myself. I am Tristan. I am filling in for Jimmy. Jimmy is the one that usually handles all of these hosting. I'm filling in for him because he's flying off tomorrow, I think, to Japan. We don't have name tags anymore. We used to. And if you have any Ruby tips for later, then please prepare them now so that when the Ruby tips comes, you can have them later. Speaking of Japan, if any one of you had been to Ruby Kaigi, I think one of us here has been to Ruby Kaigi. You have been. Mats has been talking a lot about these things. So there is this article by Square about things that happened at Ruby Kaigi. So apparently Mats talked about performance, about the new garbage collection, like the garbage compactor that makes garbage collection more efficient. Concurrency, about how threads, like how Mats doesn't like threads, for example, and would rather have a different type of concurrency model. He talked about not liking tests. He said, I hate tests. And I just realized I'm not casting my screen, so you're just looking at a blank thing. Let me cast my screen. There. So Mats was saying that he hates tests, that he would rather have something that already, like he feels that tests are not dry, that you're repeating yourself, but as human beings, we cannot trust ourselves to write things correctly. That's why we still have to write them. He talked about annotations. He talked about typing. He talked about how he would prefer Ruby types to be. So if you're interested in like a good summary of what happened at Kaigi, then I will send this link to the Ruby Facebook group and also to the notes at the meetup group. All right, then I have to cast again. Okay, so our first speaker is from Rapid River. His name is Wai Hon, and he will be talking about cost-effective two-factor authentication. So please give a hand to Wai Hon. Yay!
Oh, yeah, sure. Oh, what happened? Let me see. Hey, help me out. Oh, it's not. Hey, can you help me out with this? Oh, okay, okay, it's coming back. Right. Hi, good evening, everyone. Can you hear me? Yeah, okay. So yeah, these are the topics for this evening. Cost-effective two-factor authentication. Yeah. Yeah, a bit about me. As Tristan said, my name is Wai Hon Yu. Yeah, I prefer to be called Wai Hon. Yeah, I'm currently with the Rapid River software. Yeah, on the social media. Yeah, I'm on GitHub, Twitter, LinkedIn. Sorry. What's that thing?
The share screen.
Screen.
No, the share screen. I didn't get the screen.
Oh, sorry.
Why is it? Oh, let's go back here. Display. Here.
Okay.
It's gonna be a bit weird.
Mm-hmm. Sorry?
Are you gonna be okay with this?
Like this?
Okay, you can just put it.
Something like this?
Record as many meetups as we can, so that
Turn it off.
if you go to the Engineers
Can?
Mind YouTube channel,
Okay.
you'll find all of our recordings there.
Okay, sorry. Let's continue. Yep. I think probably majority of you have heard about two-factor authentications. Probably just refresh. Yeah, it's a way to add additional security to your account, right? The first factor would usually be your password that is like standard for any or most accounts, right? Yeah, a common second factors nowadays is a verification code that you could retrieve from an apps like on your mobile device or on your computers. Yeah. So conceptually, two-factor authentication is similar to a security token device. Yep, that certain banks in some countries, I think including Malaysia, I have like some of those. Yeah, from banks like HSBC and OCBC. Yeah, that is like required for online banking. Yeah, so other names for the 2FA includes like OTP, one-time passwords, as well as the time-based one-time password, TOTP. Yeah. Okay, this is later on there will be a demo, and I think this particular subject is inspired by or adapted from a client project. I mean, from a project that we do for clients. So without going into like very details, I just share some high-level requirements or constraints from that project. Yeah, from the business perspective, yeah, the business people are saying that on client side, it has to be like the whatever we implement or whatever we use, yeah, should be compatible with the Google Authenticator, which is available free, yeah, on the Google Play, yeah, as well as the App Store, yeah. That is like a very high level requirement from the business. Yeah, from the technical perspective, yeah, we need to find a gem, like in this case, yeah, we are using Ruby on Rails on the back end, so we will need to find a gem or a libraries, right, that make adding the two-factor authentications to a user model simple. Yeah, and another constraint that we have is that we do not use those common authentication gems such as device. Yeah, we have like a kind of like homegrown type of like authentications. So I think out there are quite a number of gems that like work well with device, for example. But in our case, we couldn't use those gems. Yeah, it has to be able to integrate with our homegrown authorizations. Yeah, so that is the so-called second constraint. Yeah, and we found this lightweight gem called Active Model OTP. Yeah. So this is the link to the GitHubs. Yeah, basically, this is a lightweight gem, as I said, that has a key dependency on the ROTP. Yeah, it's just kind of like a wrapper or helper gems. Yeah, underneath is actually using the Ruby OTP version 4.0 and or higher. And what is this ROTP? Basically, it's a Ruby library for generating and validating one-time password. Yeah, both the HOTP, the HMAC-based OTP, as well as the time-based OTP. Yeah. And this is like giving the name of the gem, like this is the way to install the gem. Like usually it's like, in our case, is installed through the gem files. Yeah, Active Model OTP. Let's move on. Setting up your model, in this case, we're talking about like user model here. Yeah, that is, we are not like using, as I say, not any of those like device gem, for example. Okay, there are a few simple steps. Yeah, we need to add this field called OTP secret key to your user model. Of course, this name is default, and actually if you do not quite like this name, right, you could actually customize it. But in our case, we just accept the default, which is called OTP underscore secret underscore key. Yeah, we have done it through migration like this. You have to add that key yeah, to our users model. And we run the db migrate. Yeah. And secondly, we have to add this directive called has one-time password to our user models. And this particular directive will provide a few useful methods to be used later on. Yeah. Okay, let's look at a bit more about the OTP secret key. Okay, this new field is saved automatically when a new user object is created. Yeah, as part of the gem. Yeah. And in our case, actually, we are actually adding this two-factor authentication mechanism to our existing model. Yeah, meaning you already have an existing user's record. And there are actually two options about that if you are adding it to an existing user model which already have existing record. Yeah, you could actually run a migration, or technically it could be a rig task or something similar. Yeah, to popular or to update all the existing user records. Yeah, with this method from the ROTP libraries called ROTP base 32, random base 32. Yeah, like in our case, because as part of the requirements, we don't like force everyone to use two-factor authentication. We leave it as an optional. Yeah, therefore we're actually using something more on the second option. We only generate or update this particular field Yeah, when user choose to enable the two-factor authentications. Yeah. Okay, let's look at some of the helper methods provided by the GEN. With that OTP secret keys set up, yeah, and populated, right? You could actually, of course, this is something like probably like useful, maybe like during development or testing. Yeah, so yeah, you have this method called OTP code. Yeah. And this one is just to illustrate that this is, I'm actually talking more about the time-based OTP here. Yeah, let's say after 30 seconds, yeah, the OTP code will be changed. Yeah, it will be changed to another code. Yeah, this is a time-based OTP. And there's also a function, depend on your specific user requirement, that you could actually override the current time. Like just now in the previous slide, the default time for the OTP would be the time now, yeah, which is effectively time now. Yeah, you could override it by, I couldn't, like in our case, we don't use this, and I'm not quite sure what would be the use case. That might be a use case for this. Yeah, you want to override the time, but this is basically just to illustrate if the input, if the time is different, the code, which is a function of the time for a time-based OTP, would be different as well. Yeah. Okay, this is the actual one that we will be actually using, authenticating using a code. Assuming the OTP code at this particular point in time is 1x6522, and when I authenticate the OTP for this particular user using these particular values, yeah, this will return a true D values. So I say true D, it's not a Boolean true, but it's a true D. It's a non-nil values technically. Yeah, in fact, the underlying method that return this value is actually from the ROTP. Yeah, the ROTP library. Yeah, the ROTP libraries. Yeah, let's say if we were to wait for, let's say, 30 seconds and try to authenticate calling the method using the same code, so logically the code will be different, and therefore this particular call will be a falsy. Yeah, will return a falsy value. Technically, it's a nil based on the current version. Okay, there's also this concept called drift, right? If you've allowed like if you allowed the older code to be validated as true, yeah, we could actually pass in an option called drift, right? And it takes the number of seconds. Yeah. See, in the previous code, if I do not use drift, right? So after waiting for 30 seconds, the code will be changed, and this particular call will return a falsy values. But if we were to use a drift, pass in a drift, we could still, I mean, the older code generated like 30 seconds ago, right, can still be validated as true. Yeah. And in our case, we also implemented an additional, what we call an additional options called recovery code. Yeah, basically the code is that in case you do not have access to your mobile device that generate the code, or the computer that generate the code, so we actually allow the users to use the recovery code on a one-time basis. Each of the code can be used only for one time to get access to the system. Yeah, if you use GitHub, I think probably you might be like using two-factor authentication, then they also have such a features called recovery code. Okay, let's move on to a demo apps. Okay, I have created a demo apps and deployed to Heroku apps. The app's name is called TFA demo. So it will be tfademo.herokuapps.com. Yep. So just want to go through the flow of signing up, enabling the two-factor authentications, then try to sign in again using a verification code, and last but not least is using the recovery code. Yeah. Okay, I've just sign up an account, and on my user profile page, I'm going to enable a two-factor authentication. Shall I wait? Probably I just wait. Okay, thanks, Edison. Oh, okay, let me try. Okay, better? Okay, I'm going to enable, as I mentioned, is an optional. The TFA is optional, so I'm going to enable. Okay, here I already have the Google Authenticator apps installed on my mobile phone. I'm going to scan it. Okay, so here's the code. Verify and enable. Okay, so these are the verification codes. Yep, that could be used, each of them on a one-time basis in case we are not able to access to our phone, for example. Yep, so I'm going to, copy it. Okay, now assuming now I've signed out, and the next sign in. Yeah, with the 2FA enabled, I will be prompted with a code. Yeah, just for testing purpose, I just key in a random number. Yeah, so this is an invalid code. Let me key in a correct one. Yeah, there it goes. Last but not least, as I mentioned just now, I'm going to show you the recovery codes. So the first factor is the password. Yeah, so assuming I do not have the access to my phone, yeah, but I have a recovery code. Yep, there it goes. Yeah. So that's the demo. And I'm going to switch back to the slide. Oops. Yeah, sorry. Yeah, this is the link to the demo apps on Heroku. This is the source code. Yeah, on GitHub. Yeah, before the Q&A, yeah, I would like to thanks my team members, Aaron, Adeline, Hakim, Tamil as well. Yeah, these 4 team members that were involved in that implementation of the 2FA for our client. Yep. Is there any questions?
Any questions for Whitehawk? Two-factor authentication.
Yep.
How do you when you scan for code, you use your phone, and how about if you use iOS, you scan your code?
Yeah, I'm also actually using iPhone.
You use browser on your phone. No. How do you scan QR?
You use browser on your phone. Let me see. There is another option is, I'm not sure whether just now you, let me try. I could try. Actually, there's another option is to manual copy the code and paste it into the Authenticator apps. What's, yeah, you mean you are browsing these apps using a phone, right? Mm. Right. Right. Mm. Right. Yep. Yep. Mm. Yeah, let me show you. I quickly sign up another user. Yep. Let's try with another user. Have I used this before? Okay. Yep. Yep, you use your phone, sure. Yeah, I know. So with only one phone, you cannot. Yeah, I know where you're coming from. You can't possibly use that phone to scan that image, right? So another option would be for you to copy paste the account name and the key into the Authenticator apps. You see?
For example, because a QR code is just an encoding of data.
Right.
So usually, whatever it's encoding, it's usually a URL. So you just link the URL there, tap on it, then through your intents or whatever iOS calls it, opens the authenticator. It's just data.
Yep. Yep. So yep, you copy and paste the account name as well as the key into the Google Authenticator apps. Yep, then you will got it. Of course, with the QR code, it will be more convenient. Yep. Mm. Yeah, so you copy paste the account name and the key in that case.
I'll just do one thing.
Yeah.
Just link directly to the authenticator.
Mm-hmm. Probably can something be done. Yep.
Any more questions for Whitehawk? Yeah.
So, what are the challenges you face when
The testing of this two-factor, the challenges. Sounds, I think, not that complicated actually. I mean that flow just now that I show, do you see like which part is like more complicated one? I mean for our QA team, they find it like quite okay. It's not really complicated to them. Yes, yeah. Of course, in our test, as I mentioned, like when we write the test, like say RSpec, right, and so on, we rely on the OTP code. Just now, I also actually show, right, like in the actual apps, we do not actually use that. We use the authenticate OTP. But in our test, we need to know, let's say for particular users, right, what is the current OTP code at that particular point in time. So we will actually retrieve that and another call to say authenticate using that code. Yep, and verify that it's working all right or otherwise.
Questions? Otherwise, give it to
Sorry, I have a shout out. I mean, can I do a shout out first? Huh?
Share the screen again.
Yeah, I'll share the screen. Yes. Yeah, so a few more slides, please bear with me. Yeah, just would like to announce that Rapid River is hiring. Yeah, yeah. A brief introduction about us. We are Malaysia-based, remote first, and yeah, we are a software consultancy company, and you can actually find out more about us rsoft.co/about. Yeah. Currently, we have opening positions for Ruby on Rails, Elixir, React. Yeah, we also are looking for technical project managers. Yeah, for more details, you may visit our careers page. Yeah, these are some of the benefits. As we say, we are remote first. Yeah, so we could, yeah, most of the time we could work remotely. Yeah, only when there's like a meeting, sometimes that benefit from face-to-face meeting, we come to the office. Yeah, so of course, a work laptop, a desk in office. Yeah, the company offer free office lunch if we come to the office to work. Yeah. Yeah, there is also a monthly well-being allowance, GEM in this case. Yeah, medical insurance, learning allowance. Yeah, we don't need to ask our boss for approval. We've been allocated a fixed learning allowance every month. If you do come to the office, the parking will be provided or can be reimbursed. Yeah, please get in touch with us. This is the email, work with us at rsoft.co or the careers page. Can I say?
Right now it's 200.
Yeah, $200.
That's like no questions asked. Like what Carlos is saying, if you have more, just hey, why not?
Yeah, thanks. Hey, can you help me with this? I'm afraid I may break the thing.
Okay, so for our next speaker, it will be Edison.
Yeah, I'm not Edison.
Oh, yeah, please, yours. Thanks.
How arrays work?
You need it?
I
Yes, I do.
Any of you ever tried
only
one
Q&A.
time
Are you gonna walk around?
arrays
Yeah.
Do I need to wear the mic?
Huh?
I need to wear the mic, right?
You have to wear the mic for the.
How many of you have actually
Where's your
implemented
This is the non-touch bar version.
RFC?
So
When you say something,
you need to wear it.
Okay. I gotta click on it. Okay, thanks. And just cast this also.
So put it into your pocket.
Okay.
And also make sure you share my screen. You share the screen.
Oh, how does that work? Just mirror.
Just me.
Just steal my data.
something interesting, a solved problem, but you want to
You cannot detect it.
I would recommend
Maybe it's not.
doing
Oh, okay.
one-time password, like
Now it should
implementing
work.
it yourself.
Oh, yeah, now it's. Oh,
Go
shit.
through the
Shit.
RFC.
Wait
The
first.
All good?
lays out the algorithm for you. The RFC is 6238. Right. Just Google that, and then it will give you some Java code with some bit shifting. It will be interesting to convert that into Ruby and find out exactly how
I'm going to share because I'm going to capture this screen.
Okay.
So also, can you turn off the light?
Oh, yeah.
Yeah. Okay.
Okay.
Good.
Okay. Okay. Can I start? Okay. I'm actually incredibly nervous. I'm Edison. I work with Faith. So today I'm going to be talking about how arrays work. Pretty simple stuff, but yeah, just bear with me. So I actually wrote the same article and published it on Dev.to as well. So if you're onto the Dev.to, the developer platform, feel free to check me out. I'm telling you that because it's actually kind of relevant later. So yeah. So, since we are talking about array and we are in Ruby Meetup, so let's talk about Ruby array. Right. In Ruby, this is totally valid, right? What's happening right here is that you have an infinite loop that's keep adding a 0 into the array. And then what I'm doing is just printing out the array size. And to us, this seems totally normal. You just keep adding stuff to the array. It's like an infinite array, right? You don't the memories work under the so yeah, like, hold up, did I just say like infinite size array? Because that's not a thing, right? Like, infinite size array is not a thing. Like, there's always a cost to something in software development. And in this case, it's like memories cost, right? So actually, the arrays that we just saw is not infinite, but it's more like a dynamic array, right? And to understand this, we need to go deeper. And by deeper, I mean the C code, right? So this is sort of what memory allocation looks like in C. If you have never seen this, that's fine. Like, I'm not a C developer, so yeah. But basically what this is doing here is that there's a function called malloc. You know how people always mention malloc and you're like, what are they talking about? But you're gonna be one of those persons soon. So malloc basically means memory allocation. What it does is it's a function that takes in a byte size. So how much memory I need to allocate to you. And it returns a void type and you can cast it to any type that you want. So what's happening down here in the usage is that I'm telling the malloc function that I want 100 pieces of memory blocks that's the size of an integer, right? And that'll give me that much memory space. If you do that in practice, that's sort of what it looks like. You're telling you that, oh, I want to store 4 integers, give me that big of a space. So this is not actually how you make an array in C, right? But you can think of it as what's happening under the hood. So appending to an array. So if you want to append to an array, like, okay, you add 1, that's fine, that's easy. You add 2, pretty easy as well. 3 is fine, 4 is fine. But what really happens when you try to add the 5th element? Right, like I said earlier, like we only ask for 4 blocks of memory. So what happens when you try to add a 5th one, right? So plot twist is you can't, right? But how come Ruby is allowing us to do that, right? There must be something happening under the hood. And you know how Ruby is always about like developers' happiness and all that stuff, right? So the reason we can't do that is because array is a linear data structures, which means that all of the values are stored in contiguous block of memories in the memory. So if, for example, if this is this big, right, like you cannot guarantee that the space that you need right after it is available to you, which is why the program won't let you do it. So to understand this, let's try to dig into like what is actually happening under the hood when you call a append shovel operator, right? So we look into C code, and you can see that when you push something into an array, there's a function. Like you don't really have to understand what this code is doing, because I don't. But you can see that it calls to a function called this is kind of what it looks like, right? In Ruby, you're like, oh, just S stub is fine. This is just like a mess, right? Yeah. So remember how I talked to you guys about like me posting this on Dev2, right? I pretty much finished the array part of it, so that's pretty fast. But this is now talking about the blog post. So after I published the blog post on Dev2, someone actually commented a question, right? So the question was, so this is after our conversation where I told him that every value in Ruby takes up at least a fixed size of 40 bytes to start with. So he's asking beyond that. He's asking, is it possible for an object itself to grow beyond that size, right? So that was a really good question. I thought, okay, I'm gonna try to figure this out, right? So what first came to my mind is just I can write a piece of looks like this. What this is doing is basically just having an initializer, and then I have a instance variable string, and I'm just like adding it times 10,000 times, right? And then I'll print out the memory of the instance, and then also the memory of the string itself, right? At first I thought, like, well, this is gonna work, right? And then I saw, oh, it's only 40 memory bytes, right? So I basically answer here and saying that, oh, can't really grow beyond that size, right? But that's not really true. I thought about it. The problem is not about having the large attribute, right? It's more about having a lot of attributes. So if you see this instance variable, now instead of having one string that's 10,000 times long, I'm having it just 10,000 different instance variables, right? And lo and behold, this is what the size of the new instance is gonna look like 8,000, right? The value doesn't really matter, but this makes me think that the reason that I didn't see at first was that all Ruby object was storing was just the reference, the pointers to the actual. So the variable is actually stored in a totally different part, right? And then whenever I add stuff to that string, it's just gonna keep getting reallocated somewhere else. But the object itself is gonna remain the same. It's gonna have the same exact pointer. Well, it has to change at some point. But that's basically how it works, right? So this gets blown up, and I'm telling you about a story about like the guy commenting on my article is because like it's always been like a fear of mine to like publish something, like I don't know if people are gonna criticize me, like even right now presenting, right? Like this guy, I don't know what he's talking about. But then I posted it, and then like someone commented some great questions, right? And then that prompted me to think even more about myself, like what can I do more to understand more. And then just because of a simple question, like I learned so much more like from that. So the takeaway is basically, I guess, if you haven't seen that just now, Object Space is a module that I use to let me interact with living Ruby object. So as you can see, you need to acquire it, Object Space. So there's a bunch of stuff in Object Space that you can use. So yeah, you can use that to look at the memories, living the Ruby objects. So dynamic arrays in Ruby are not free. So whenever you work with big arrays, just keep that in mind, right? So indices in arrays are offset. So I haven't mentioned too much about it just now, but you know how arrays are stored in contiguous block of memories, right? That means the pointers only point to the first element, right? So when you do a square bracket and put a number after it, what it's really doing is just telling that pointer that how many offset do you want, right? Which element is it? So there's something to keep in mind because I never knew that indexes were part of like array memories, right? Objects start with a pre-allocated space of 40 bytes. That's just because Ruby internal uses value, which is 40 bytes. And also, don't be afraid to publish what you know, right? Like, write more, right? People might not like your articles, but they probably just ignore it. But every once in a while, people are going to comment on it. People are going to ask questions about it. And then what benefits is really you yourself, right? You're going to learn more. You're going to interact more. Put yourself out there more. Don't be afraid to publish what you know. So, yeah, shameless plug. Follow me on Dev2 if you want to read more articles. I read about Elixir and Ruby. Yeah, so that's it for my talk. Thanks. No questions.
I have a question. Oh, sorry, do you have a question?
I have actually. So I actually posted. There was one article. What was that? I actually posted an article on it, and then I think Matt's read my article from there, and he retweeted it on Twitter. Yeah, it's not this one, so yeah.
I have a question. So you mentioned that be careful with dynamic arrays.
Mm-hmm.
What do you propose we do so that we don't trip with?
Well, that's a really good question. To be fair though, like normally when you work with Ruby, right, you don't really work with large arrays. And in the events that you do, right, because it's already double the capacity, you're not gonna really be adding to your arrays like double every time, right? So the actual cost of reallocating memories is not that bad when you have a large enough array. Yeah, so linked list is another thing, right? So for example, like you see, like I was just telling someone earlier, you see, because you have to use an array which requires the values to be stored right next to each other, and then like you need to have all these random logics just to check that, to make sure that the array has enough room to grow, right? Whereas with linked list, you don't have that problem because linked lists are just scattered everywhere. So you can use a linked list if you really want to go that way. It's not that hard to implement in Ruby. But yeah, day-to-day usage, I would say, is not something to be really concerned about. It's just like for your own knowledge that this is happening under the hood. Yeah. Pardon?
When you create the array,
Mm-hmm.
you can give the size of the array.
All right.
Initially array of that size. So if you have a list, then you go and see.
I actually done that, but I realized I don't really know why. But if you initialize the array with a certain size versus if you're appending to it, the actual size actually looks different. I'm not very sure why that is.
If you're gonna create an empty array and start appending items to it, every time you reach the size limit, it does a copy. But if you initialize it with the full size,
Right.
you will never trigger the
Right.
the limit.
Okay.
So
Okay.
that's the thing. But
Fair point. Fair
every
point.
day it's not a concern. So
Yeah.
That's one.
Yep.
Underneath array quality.
Right. Thanks. Any other questions? Pardon? I'm not familiar with vectors, so can't really answer that.
So it's something like that. It's if you have a size of 2, you're gonna add 1, you're gonna expand by 2, 4. Then if you 4, you add 1, you're gonna be the size is gonna be reallocated to 8. So if you 8, you plus 1, it becomes 16.
So I don't think this is actually like exponential. I think this is more just doubling every time. Yeah. It doesn't grow like that, it just grows. Yeah. What? Oh, okay.
Any more questions for Edison? No? No more? All right.
Right.
Give it a hand for Edison.
Thanks.
He was
It's you again.
Help you plug out.
Thanks.
Whoa. Okay.
Who will be talking about garbage collection?
Yep.
Today are all
Yeah. Can I pause them? Yep. And I'm gonna plug in. I gotta help you. Don't worry. So you're gonna cut it normally. Okay. Are you gonna share codes? No. Oh, let me give you the projector. Right? Yeah. Okay. Then I'm gonna help because I cannot capture it. So this is for me. And where this? You're gonna move around? Yeah. Okay. Stand still. Stand still. Then you can put here. Okay.
Is it secret? Okay.
Yep.
All right.
How do I get the setting? Can I make it smaller first? Because everybody had that. Oh, you're the same as me. Good. I need the setting. Oh. The screen is on the other side. How do I move it here? Do you know how to move it here?
Move what?
Move the windows of that? Because I plug in the device.
Move the windows. What windows? Sorry.
Because I actually cut this to the, because I plug in this, so
Right.
it treat me as an external.
Right.
So the window for the setting actually went there. So do you know how to make it better?
I don't know. I don't know.
For the setting.
I don't know. I'm sorry.
It's fine. It's fine.
Yeah.
Wait. Okay. Come on.
So you have to go to this place or live stream issues. Yeah. Oh, so because you have to just
Oh,
you're gonna move there. I'm gonna command you.
It's responsible to allocate memory for use by new objects, to identify which objects your program is no longer using, and reclaim memory which are made from unused objects, right? So before we talk about garbage collection, right, I just want to have a very brief introduction on how Ruby allocates memory. So calling malloc is actually not free, right? So what Ruby does is Ruby requests memories in chunk from the operating system, right? And this Ruby heaps, Ruby actually requests for a page. So a page is actually a chunk of memory, right? And one Ruby heap page is actually not one OS, does not equal to one OS page, right? So one Ruby heap page is actually 16 KB, whereas one OS page is 4 KB, right? So what does this heap contain? This heap contains, empty slots. So this empty slots is where Ruby allocates Ruby objects. So when Ruby first starts, right, it allocates 24 pages. Each page contains 408 slots, right? So this talk, I would like to just share how garbage collection has actually evolved in Ruby, and what are they doing properly, and what are they not doing right? So the first version, 1.8.7, they actually introduced
mark and sweep algorithm, a very basic one. Just go through it and see how it works, right? So assume that this is the objects in our Ruby program, right? And all our objects are actually referenced from the root. Okay. So what happens is when the GC starts, GC actually starts traversing from the root, and it checks which objects that it refers to, and from there continues to the next object that the other object refers to. So what it does, it actually marks those objects which are live, which has reference to, right? So hence we are marking it in this color, right? So these two objects are actually not referenced by the root, and they're not actually being used. So what the GC will do is GC will just remove them, unmark those guys, and done. So that's our mark and sweep. So the disadvantage of this mark and sweep algorithm is this: the mark and sweep algorithm, in order for our GC to run, right, it technically has to stop the whirl. So stop the whirl meaning it's actually a very common term used by Ruby developers from the talks that I have seen in YouTube from RubyConf and stuff, right? Stop the whirl meaning that the GC has to stop the execution of a Ruby code. Why? Because if it allows our Ruby code to execute, while it's actually traversing, new objects can be created. So we don't want that to happen. It actually stops our Ruby program's execution, does its mark and sweep, and then allow our program to run. That's what's happening. So the Ruby developers actually noticed that this was slow. So their goal was to actually not to cause the Ruby program to freeze for a very long time. So in Ruby 1.9.3, they introduced something called lazy sweep. So what lazy sweep does is, the minute that the GC starts, what it does, it tries to reclaim memory of this unused object from one heap first, right? If in that heap it could not find any free slots, it continues to the next heap, right? So when it finds a heap which has unused objects, it removes the unused object. Basically reclaims the memory, and it stops. It allows our Ruby program to run. So here the execution time is actually not that long compared to the first implementation of mark and sweep, right? Okay. So in Ruby 2.0, they introduced something called bitmap marking, right? So before we understand what bitmap marking is, we need to know why it was introduced first. So the previous two versions that I talked about, right, they are actually not copy on write friendly. So in modern operating systems, right, what happens is, like, if we are using a forking server, right, a Unicorn web server, I have not tried this in production yet, but these are from articles that I've got info from. So what the Unicorn web server does is, it has a parent process which is loaded with a Rails application, right? And then when a request comes, right, it's gonna fork from the parent process, and that forked child process, it's gonna point to the parent process. Why they do this is because when we boot our Rails application, the Rails code and most of the objects initialized at the first stage are technically same. So the way that they justify is both of these programs can actually share the same memory. They don't have to copy the same objects into two separate processes to save memory. So that's the purpose. But
But the later two versions, what happens is when, so basically copy on write only copies this objects, creates a separate private copy of this shared objects to the child process when it's mutated by something. So the later two versions, the GC, what it does is, in order to mark these objects, it will actually set a specific flag onto the object itself. So what it does, it goes to the heap and it mutates the object itself. So when that happens, the OS will intercept and actually copy the whole page into the child process. Hence, we have redundant objects both in parent process and the child process. Hence, we use more memory, right? So what was introduced in 2.1 was a bitmap data structure where the flag which we are actually using to determine whether the object is live or not is set in a separate data structure. So when the GC tries to mark the live object, it will not mutate the object itself, rather it will set a bit onto that data structure separately. So a heap will have a bitmap data structure to itself. So all these heaps will have their own bitmap data structure, right? But still, what happens is our GC still consumes more time to reclaim memory from the unused objects. So what was introduced in the next version was a generational garbage collection where we separate objects into two categories: old objects and new objects. So the reason is new objects that we create technically there's a high chance for it to die young. It will not be available for a much longer time. Not all the objects. So what happens is when the GC starts, it's gonna actually it's the same algorithm. It's gonna start marking the objects from the root and remove the objects which doesn't have a reference from the root and promote this objects that survived that GC into a second generation called old objects, right? So the advantage of this is the next time when we have new objects being created in this new section, the new generation, right? We are technically not going to remark that objects on the older generation, so we save time, and we only run frequent GCs on the newer generation objects only. Yeah. So as you can see here, right, we first from the root we realize that it's actually referencing F, we mark F, right? And then from F we know that it's referencing C, we mark C, and we realize that E is unmarked, we are going to remove E from there, we're going to promote F to the next generation, and we did not traverse A, so we save time. So that's the reason behind it. Okay, but in this, and we obviously unmark it, and in this implementation, right, there is actually a bug. So the bug is actually this. So as we all know, right, when we run major GC, major garbage collection, right, does not actually run frequently. Only minor garbage collection in the minor area runs frequently, right? So when a new object is being created, but it's referenced by the old object, what Ruby will do is Ruby will technically remove this object. Oh, damn it. Ruby will technically remove this object because this object is actually unmarked and it's not reachable from the root. So the workaround done by the Ruby core team is to actually use write barriers. So what happens is each time when an older object references a new object, that specific object which is referencing the new object will be added into a set called remembered set. And the next time when the GC runs on the minor stage, it's going to traverse objects from the root and also traverse objects which are in the remembered set. Right. So in the next version, we had symbol GC. I did not do much research on symbol GC, but the only thing I know is like for the previous versions, symbols are not being garbage collected, but from 2.2 onwards, they are actually being garbage collected, but I have not done a very deep research on that yet. All right. And yeah, another thing also, as I've told earlier, right, in 2.1, we have actually solved this copy on write problem. But in 2.2, the problem actually reoccurred again because the Ruby core team now changed the algorithm of the minor generational GC. What it does now is, it's not that when you run garbage collection on the minor section, right, you should actually get past three garbage collections. Only if you pass 3 garbage collection sessions, then you are actually promoted to this major, you're considered an old object, right? And the same thing also, the same problem which is being repeated again from 2.1 is, whenever we run the garbage collection on the old objects, it's still taking a much longer time, right? So what we do here is, we are going to do, in 2.2, we have introduced a new algorithm which is an incremental major garbage collection. What it does is, the idea is basically this. We are going to run the GC on the major section for a second, stop, run the Ruby code, run the garbage collection again, allow your program to run, and it continues like that until it's actually, the marking is complete. And the same thing happens when the marking is complete. It's gonna start sweeping your objects. The sweeping is also the same thing. It's gonna alternate between sweeping for a fixed time, for a small amount of time, and then allow your program to run until the sweeping ends. So that's how it's being done in 2.2. So in this incremental major garbage collection, right, the algorithm, the way they actually mark objects are actually different. So they are using this tricolor marking, which is white. White means the object which is to be collected, which is no longer in use. Black is there's no reference to white objects, and it's reachable from the root. And the gray object is reachable from the root, but it's not scanned yet. So an example is this, right? So what happened is, we start from the root, we mark the root black, and we mark the objects that we're referring to as gray, right? Then we select the next round. We start selecting one of those gray objects, and we mark its reference to be. We mark A and F to be black, and we mark its reference to be gray. The same thing happens. So we pick the next gray object, and we check whether it has any reference or not, and we change its color to black. That's about it. For in this case, all the objects are actually live, and there's nothing to be garbage collected, right? And yeah, that's all. Yeah, thank you. Thank you. Thank you. Any questions for what are groups, for example? Yeah. All right, good question. I'm not sure, because to be honest, because this terms, right, are actually not officially documented in the Ruby documentation. This kind of diagrams are actually got it from the RubyConf videos. They said this root is actually a magical variable. Don't care about it and stuff. Yeah. Yeah, because this is actually in a tree structure, and how I understand it is like, each tree has a root, and it starts from the root. That's why. Yeah.
More questions? I have a question. We were talking about heaps. What is the heap?
The heap is the place where you store. Ruby actually allocates a Ruby object. It's a data structure that is used by. Am I right?
Same 40 bytes that you were talking about?
45, I think, is just one of the remember you mentioned R value. So R value are actually used by 45.
Yes.
I think just when you take the block of the page itself, that is.
Yeah, so actually an R value is actually assigned in one of the slots actually. that R value is actually, it contains many different, because R value, right, is not a single type. It's a combination of multiple types, like, array is also R value, string is also R value, stuff like that. Yeah, an object, yeah.
The thing about heap is the root can be changed around.
The root can be changed around.
Yeah, so AKA in CS is also called priority queue.
Right. But I think, but I think this heap is not that heap.
It's actually the works the same thing. I mean, I'm not a Ruby guy, but from
Right.
others it works similarly.
Right. Okay. Right. So any other questions?
Alright, so I will take over. Give a hand to Navindran. Thank you so much. That's a lot of Ruby internals, like two talks with Ruby internals. I will ask. Yes, I will just quickly wrap things up. Does anyone have any Ruby tips today? Oh. Okay. Any Ruby tips that you prepared? You had one? Do you need a laptop, or you can just speak? Yeah? You can come here for the RFC, the IETF RFC. If you want to find out exactly how one-time passwords and time-based one-time passwords work, what is HMAC, all of these algorithms. There's a nice book called Ruby Under a Microscope. It talks about like how arrays work, why arrays work. It talks about some of the stuff that Navindran was talking about. It's a bit dated though. It's like a few years old, so it didn't capture some of the more recent garbage collection techniques, but it's actually very interesting, like how exactly are classes implemented, how different are modules between classes, like in the C code, how are they different, for example. So it's a very, very interesting book if you really want to know about the internals of the language that you're programming with. If there are no more tips, we will go to the hiring shoutouts. I think Forkwell has something. Yep. Where is your slide? Okay, there you go. Let me just cast.
Maybe I just speak.
Yeah, but you don't want the live stream to hear you?
Oh, yeah, okay. Maybe that's fine.
I mean, we can.
Hello. So my name is Rubina. Maybe you go to the first page. Yeah. Well, my nickname is kind of like Ruby, or you can call me Ruby. So I'm actually an imposter. I'm not a Ruby developer. I'm here representing Grooves. Does anyone know what Grooves is? No? You want to take a guess? Yes, okay. So Grooves, we create, at Grooves we create HR technology for the future generation. One of our platforms is called Forkwell, and it is catered just for software developers, right now in Japan. So now we're expanding. Our expansion hub is in Malaysia, and we want to provide Forkwell for global software engineers. So one of the things that Forkwell does is that it actually helps developers determine how they can work faster and how they can work smarter. It can even actually determine throughout the week if you code the best or the worst during the week. So if you go to the next slide. Sorry, I'm so nervous because we're like the only two girls here. It's kind of intimidating. Okay. So if you actually just take out your phones right now, if you just scan this QR code, please, 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 warm up to me. You have to just scan this code. So we created this landing page. It's basically a subscription for job mail from Forkwell. And it's opportunities for you to create a portfolio on Forkwell. It will actually benefit you in the future if you want to see how your skills are or like your routine, what it's like. And also, you will get offers from Japanese companies. So it's a great opportunity for developers. Yeah. Do you have any questions?
Wait, I would like to add.
Sorry.
Basically, at this moment, we're still expanding, and basically, if you are a developer and you want to work in Japan in the future, let's say a few months from now, 1 year from now, this is the platform where you sign up. So if you want to work in Japan, so that's our focus area.
Yes.
And basically, through this, we're also trying to build a community here in Malaysia, but also in ASEAN, and trying to get to know you guys as developers, what you guys want. So that's why we're here today. So if you want to connect with us, like come up to us, don't be shy, can exchange business cards, and also sign up there. Basically is to have a, I guess, registration in a sense where in the future we can contact you once our product is ready. And
Okay. Thank you.
any questions? I see very confused faces. So
They will be here until like later,
Yeah.
right? After the event.
yeah.
They will be here. If you have any more questions, you can just approach Hoisan or Ravina from Grooves, Forkwell, any of those two, and we'll find.
Any questions?
Yeah,
No?
thanks.
Okay.
Do we have any more hiring shout-outs? Yes, we have one from Caleb. Do you want to be on the live stream? Do you need something cast on the thing?
I just need a web browser. Hello.
Just cast. We have a casting.
Okay, just a tab in a web browser should be fine. RSoft.pro. Do you have it bookmarked?
No, it's a different RSoft.
Yeah, it's a slide.
Yeah.
Thank you. Okay, hello everybody. My name's Callum. I'm a co-founder and CEO of Rapid River Software. We build web applications for clients. We also do some data engineering. Basically, we build data warehouses on Hadoop ecosystems, things like that. And we are hiring. This is our website. And let me just tell you a little bit about our company and our hiring process. Ooh, your mouse is so sensitive, Tristan. No, at least it scrolls the right way. Okay, so I'll tell you a little bit about our open positions, but I just want to tell you a little bit about our company first. So on our careers page, you can find out a little bit about what we're about. So if you join us, some of the perks and attributes of our company are, firstly, we're a remote-first company. We highly believe in the remote-first philosophy. So all of our processes and working practices are set up to support remote-first people. So if that's something that you're interested in, then definitely check us out. However, we do actually have an office here in Bangsa South, actually, over in the Vertical. We have an office just to support flexibility if people like to prefer to use an office and go to an office every day rather than work from home or from a co-working space or a cafe. You can work in our office too. We provide free lunch for people who come into our office. We give our people an education budget to help with self-improvement and a few other perks, the usual kind of stuff. Some of the things we care about, we're very much into getting things done. Also, technical excellence in the way we do things. We don't just try to solve problems, but we try to solve them in the most correct way possible. And so if you want to see more about what we care about, go and have a look at our careers page. And finally, on to the positions that we have open. As you can see, we're hiring for Rails developers. We have a lead Rails developer position, also a Rails and Elixir position, a Rails and React position. Basically, we're in the business of building web applications, so we tend to do a lot of Rails development and a lot of JavaScript development. Okay, that's about all I have to say. The last thing I did want to add, though, is I just wanted to give you a little bit of information on the kind of salaries that we pay people. So I did note it on my phone, but I've left my phone over there. But from memory, we tend to pay junior developers between 6 to 8K, mid-level between 8 and 11K, senior developers between 11 and 15, and then for principal developers who are a mix of architect, leaders and mentors, and people who interact with our clients, basically technical leads on our projects. We tend to pay, we can go as in the range of like 15 to 18K. So if that's the kind of thing that interests you, then come and talk to me. Okay, thank you. Kristen.
Hello. And if you have any more questions, he will hang around for a bit more after the event. Does anyone have any more hiring shoutouts? Like, does Fave have? I think, Joey, you were supposed to speak something, right? Right? Yeah. Do you have a website that you want?
Yeah, can you just go to careers.myfave?
Careers.fave.com?
Myfave.
Oh. What is that?
Careers.myfave.
Okay, cool.
Fave is hiring software engineers. We are hiring. Our HR person was here, but she left earlier, so she has a better understanding of this. But I'm just standing in. Just head over to careers.myfave.com, and then you'll see all our open positions, and apply from there. There we go. So here are our open engineering positions. We got backend, QA, front end. We got the whole set. So just feel free to apply. careers.myfave.com. Yay. Okay.
All right, okay. And Joey will be around as well, right? After. So if you have any questions about Fave positions, then you can just talk to Joey.
Yeah, I think we have a few of different teams here, so the DevOps, where like if you want to know more about certain area in the company, we can talk to them.
Are you able to talk about your tech stack?
Yeah, we use Ruby mainly. We have also an Elixir. So because we sort of have a different apps here, but mainly it's Ruby.
All right, let's get back. So that would be it for this Ruby Meetup number 62. We will all see you again next month. Again, if you want to find out what everyone has been talking about, just go to the Meetup page or to the Facebook page. And if you want to know what else is happening in KL as regards meetups, you You can go to devcommy.com/meetups. I think tomorrow is Rust is happening, right? A Rust meetup is happening tomorrow. And then, I don't know. I need to go to... Let's go to the page, and then let's find out what is happening in KL. There's a Ruby meetup today, there's a Rust meetup tomorrow, and on Thursday, there's Women Who Code Test Automation Talk, if you're going there. All right, and then July is Angular Malaysia, if you're interested in Angular.